Ben, sit down. On page 17, I want you to look at Dana. Dana is a speed skater. We need to find the unit rate of how fast she goes around the track. In this case, the coaches want to figure out how long it takes her to do a half lap. So how long does it take her to go halfway around the track? All right? Let's start with how long it takes her to make one revolution around the track while she's speed skating. So someone read the speed skating for me, please. Ian, thank you.
Okay. Dana is skating laps to train for a speed skating competition. She can skate one lap in 40 seconds. Write a ratio. Write a ratio in simplest form comparing Dana's time to her number of laps.
Very good. So write that ratio. How many seconds does it take her to make one lap? How many seconds does it take her to make one lap? Megan Welsh. 40 seconds. Is that a ratio or is that a unit rate? Is that a ratio or is that a unit rate? Well, that's a unit rate. Very good. Now our coaches want to know how long it takes her to make half of a revolution around the speed skate track. Why? We don't really care. But our coaches want to know how long it takes her to go halfway around. You can figure that out real quickly. It takes her how long to do a half revolution around the speed skating track? Go.
20 seconds.
Wonderful. How do I write that as a ratio? How do I write that as a ratio?
20 to 0.5.
Okay, I would like you to keep it in fractions.
20 to 1/2.
20 over 1/2. Okay? So this right here is what we call a complex unit rate. It has a fraction as either the numerator or the denominator. Okay? Yes?
Why are these fractions so decimals?
You're going to see why in a second. So, here's what I want you to do. Way back in probably October, November, you learned a story about Peter and Rita. Yes?
Yeah.
You're going to have to recall the story of Peter and Rita to get this done. Tell me about Peter and Rita, Michael Bersesi. Tell me about Peter and Rita, Grayson. Tell me about Peter and Rita, Ellen. Tell me about Peter and Rita, Will.
Okay, so there's this guy named Peter. His brother named Rita. And, well, I don't know, noticed him walking on the balance and breaking it. So Rita flips upside down or something, and it makes X-ray multiply.
Okay. What skill do we use this with? Megan.
Dividing fractions.
Dividing fractions. Is this a division of fractions? You betcha. So what are you going to have to use? The Peter and Rita method, yes? Yes?
Yeah.
Wonderful. So let's take a look at some problems and we'll figure out how to do this.
Oh, found it.
Sam, warning. Please go to page 18 and look at your complex fractions key concepts. Complex fractions key concepts. Please look at it and tell me and read it out loud for us, Gabriel.
Okay, the key concept. Is this 18? Oh, fractions like 20 over 1/2 are called complex fractions. Complex fractions are fractions with a numerator, denominator, or both that are also fractions. Complex fractions are simplified when both the numerator and denominator are integers.
Wonderful. Let's look at example number 1. They gave you the, well, let's just stick with this one. Is this in your notebooks on your teacher's side?
Yeah.
No.
Great. On your student, well, whatever. Is it in your notebook? Wonderful. I'm going to rewrite this first of all using the division symbol instead of keeping it in the fraction form. So I'm going to rewrite this as 20 divided by 1/2. I'm going to rewrite it as 20 divided by 1/2. Now, based on what you did way back at the beginning of the year, you should already know what to do right here. I'm hoping that we didn't just forget it because the test is over. Scoot in, please. What do you do? Cheyenne?
Put a 1 under the 20.
Okay.
Multiply 20 by 1.
The story of Peter and Rita is what you need to remember to help you. So Will said Peter stays, Rita flips. So what am I going to do first?
Change 1/2 to 2 over 1.
Perfect. Change 1/2 to 2 over 1. Okay. When Rita flips and breaks the board in half, it becomes a Ellen multiplication symbol. So now I'm going to do 20 times 2 is 40. Okay. You should check this always, but you can already check it because we did it. 1 lap takes 40 seconds. Do these two match up?
Yep.
Yep. So you know that your unit rate is correct. Capiche?
15.
Wonderful. Michael?
So this is only for checking it, right? This isn't really part of the actual problem.
What?
The Peter Rita part.
No, you need to do that.
But is that for checking or
No,
no?
that's-
Is that fine?
That's to get the answer.
Or the answer?
I think.
In this example, yes. Kara?
So is the answer 20 seconds over?
You can't leave a complex fraction like this. You got to break it down. 40 per. Yes. Megan Eberts.
So if you were trying to find the 20 seconds for half a lap, but you only have the 40 seconds in one lap, would you do division?
We're gonna do that later. Let's stick with the easy stuff first. Give me a number between 1 and 20. Charlie.
14.
Put this on your student side. Griffin, give me a fraction we can work with easily. Not 1/2 though.
A fraction that we can work with easily. 1/4.
It's a little more difficult.
0.8.
How to write that as a fraction? Max, how do I write that as a fraction?
That would be 4/5.
4/5. Griffin, you write it 8 over 10, then you simplify it down to 4/5. Yes. Okay, make up a story problem for this. Make up a problem. Will?
Oh. Wait, never mind. That won't work.
Gabriel.
I'll take a crack at that. This probably won't go. Okay, so let's say John can run 14 miles, 4/5 of a minute, because he's like Superman. And so we want to find out how many miles he can run in 1 second.
You can run 14 what in 4/5 of a second?
Miles.
Who is this? Batman?
He's
No,
like
it's
Superman.
the Flash.
He's like Superman.
Batman cannot
No,
run
he's
that
like-
fast. Y'all-
No, John.
Okay, so Superman can run 14 miles in 4/5 of a second.
Uh-huh.
Let's figure out. Let's figure out how many he can do in 1 second. What am I going to do first? What am I gonna do first? Julia.
Well, you're gonna put 14 over 1 and 14 divided by 4.
Wait, 14 divided by what?
4
No.
14 over 1.
Good. You can switch it right now. Multiplication sign, switch it to 5/4. Yes?
Uh-huh.
They would not understand that.
I don't really.
So what she did was she took 4/5 and she moved it over here to be divided by 4/5. And remember Peter and Ray's up, you flip your fraction, and then it becomes 5/4.
Oh,
Okay. Good. What do we do next? Grayson.
Maybe multiply 14
Good. What's 14 times 5? Good. 1 times 4, Sophia. Wonderful. 70 divided by 4. How many holes are in, how many holes of 4 can I make out of 70? How many holes can I make? If you don't know, you should be calculating it in your notebook, not just sitting there like a bump funnel. How many 4s are in 70? Nicholas?
17.
17? Do we agree?
Yes.
And how many are left over? How many are left over after you find 17? Ian? 2 what? 2. 2 4s. 17 and 2 4s simplified is
What?
yeah.
1
Simplify that to decimal.
Oh. 1.2. What?
What is 1/2 is
Oh,
decimal?
50.
Yes. 17.5. Gabriel, that's a warning.
Sorry.
17.5. What was it, Gabriel?
What?
What was it?
Seconds? Miles per second?
Miles per second. So Superman can run 17.5 miles per second. Okay? Yes, no, maybe so.
Yes.
Great. Close your eyes. Hannah, you can do this too. Close your eyes. Thumbs up, I get it. Thumb sideways. I kind of get it, but I forget Peter and Retep and I need to look back in my notebook. That's why I keep a log of things. Thumbs down. What are you talking about, Mr. Seibert? Hands down. Eyes open. Good, that means nobody's stuck. Those of you with thumb sideways, you better be looking in your notebook, finding that lesson on dividing fractions and remembering that Peter and Retep story to help you out. Alright? So here's what we're going to do so I can check and see how you guys are doing. Please go to page 18. Well, you should already be on 18, right?
Yeah.
Okay. Start off with A and B.